Let us take a look at the third equation. So, by the time we must have gone through these equations, you will be able to know how to balance equations at ease. We look at the third equation. It is between methane. The third equation is between methane, CH4 plus O2 to give us CO2 plus H2O, that is water. So this is the third equation. So let us proceed to looking at how to balance that equation. We have CH4 plus O2 to give us CO2 plus H2O. So how do we go about balancing this equation? Like we have done in the previous examples, we're still going to do same. Itemize our elements at the left hand side. We have carbon to be 1 at the left hand side, hydrogen is 4, and oxygen is 2. At the right hand side, carbon is 1, hydrogen is 2, and oxygen is, can you tell me? I can hear someone say 2. Is oxygen 2? How many oxygens do we have at the right hand side? We have 3. That's good. We have 3 oxygens at the right hand side. This is 2 and this is 1. So that is 3 oxygens. We have 3 oxygens at the right hand side. So having seen that, let us take a look at which of these elements are balanced. Carbon is 1 at the left and is 1 at the right. That is balanced. Hydrogen is 4 at the left but 2 at the right. Is not balanced. Oxygen is 2 at the left but 3 at the right. It is also not balanced. So the only element which seems to be balanced is carbon. So let's see how to go about balancing this equation. Now, to balance the equation, we only have to, through trial and error method, using our pencil for a start, you ought to fix in numbers, attempt different numbers to see how they can balance your equation. So let us attempt to see how we can do that. Since we have 4 hydrogens at the left, but 2 at the right, we may say, let us, through trial and error method, place 2 in front of hydrogen. When you do that, you observe that hydrogen will now become 2 times 2, which is 4. So it is now balanced with the hydrogen at the left hand side. But placing that 2 in front of hydrogen has automatically affected oxygen. Oxygen is no longer going to be 3 at the right hand side, but oxygen will now become 2 because the 2 that has been placed in front of H2O is not only for hydrogen. It is for both hydrogen. It affects both hydrogen and oxygen. So for hydrogen, hydrogen has become 2 times 2, which is 4. This small 2 here, this small 2 is for hydrogen alone, but this one here is not for hydrogen alone. It's for both hydrogen and oxygen. So hydrogen will now become 2 times its own personal 2, which is 4. It is now becoming 4. And it is balanced with the one at the left-hand side, the reactant side. But in the case of hydrogen, oxygen will be 2 times 1 because oxygen is just only 1 here. This is just only 1 oxygen here. So oxygen will be 2 times 1, which is 2. So it means in this compound, oxygen is now 2 here. And in this compound also, oxygen is 2 here. So combining both of them, oxygen will now become 4 at the right-hand side. So it means oxygen is now 4 at the right-hand side. Now at the left-hand side, oxygen is still 2. So Oxygen has now become 4 at the right hand side, no more 3. Hydrogen has become 4 at the right hand side, no more 2. But at the left hand side, oxygen is still 2. So what do we do to make oxygen to become 4? It is simply to place 2 in front of oxygen here. So placing that 2 in front of oxygen will make oxygen to become 2 times 2, which is now 4. So oxygen is now going to be 4, no more 2. So this is actually how to balance equations. So if we check out these equations, we'll see that carbon is 1 left and right, hydrogen is 4 left and right, and oxygen is 4 also left and right. So every of these species are now balanced. All species are now balanced. So this is how to balance chemical equations. So away from the third example, so the next example is C3H8 plus O2. That is propane. Propane plus oxygen to give us CO2 plus water. So let us take a look at how to balance that equation. To balance the equation, we have our propane C3H8 plus O2. That gives us, let us take away this. We have O2. That gives us CO2 plus H2O. So, how do we balance the equation since it's not balanced? The same way we did. Left hand side, we have carbon is 3, hydrogen is 8, and oxygen is 2. We have that. At the right hand side, carbon is 1, hydrogen is 2, and oxygen is 3. We have 2 here and 1 oxygen there. So oxygen is 3 at the right hand side. So with that, let us take a look at how to balance the equation now. Since carbon is 3 at the left but 1 at the right, that can lead us to giving our oxygen, place our oxygen 3 in front of CO2. To place 3 in front of CO2, it has made our carbon to become 3. Please recall that we should not try balancing any equation with a subscript. Now I know someone may be asking, why is this 3 written as subscript? This 8 is also written as subscript. This 2 is also written as subscript. And we are saying that number shouldn't be written as subscript. Please, these are compounds, and that is their formula. C3H8 is a compound, and that is its natural formula. It is not, the 3 and 8 there are not used to balance the compound. The compound is how it is. That is to say, that is its natural formula. So don't be confused when we say number shouldn't be balanced. I mean, we shouldn't balance equation with subscript numbers. Don't be confused by relating it to the subscript numbers we have in each of these compounds, or in the case of oxygen as it is O2. Oxygen as it is O2, propane as it is C3H8 is their normal or natural formula. Those numbers there represent how the compounds appear in their structure. So the numbers are not there to balance the compounds. But what we are now doing is when compounds come together in chemical reactions to form a given compound or more than one compound, then such reaction ought to be balanced. And in balancing such reactions, we don't use subscript numbers. So I want to get this straight before we proceed to our solution. So please, don't be confused and let it be clear. Let what we have just said be very clear so that we are not confused over subscript numbers. So, with that now, let us proceed. We have our number there already. So, 3 is there. So, to balance this equation, therefore, we said that we have to place 3 in front of carbon. So placing 3 in front of carbon, carbon will become 3. But it is good to observe that the number there has made carbon to become balanced, but it has affected oxygen. Oxygen will now become 6, 3 times 2. Oxygen will now become 3 times 2, 6. And with the oxygen over there at H2O, oxygen will become 6 over here and 1 over here. So oxygen is now 7. So take note of that. It is good we take note of that. We are coming to balance oxygen. Now hydrogen is still 2 at the left but 8 at the right. So that automatically will make us to say, okay, to balance hydrogen, let us place 4 in front of hydrogen. So hydrogen will now become 4 times 2, which is 8. Hydrogen is now 8. So it is now balanced with the 8 at the left-hand side. Now automatically, placing 4 in front of H2O has made hydrogen to be balanced. It has affected hydrogen, and at the same time, it has affected oxygen. So oxygen that was 1 there before, it's now no longer 1, but it's now 4. Oxygen was 2 before when it was with CO2, but placing 3 in front of CO2 has made carbon to become 3, but it has made oxygen to become 6. So in a nutshell, we now have 6 oxygens over here and 4 oxygens over here. So oxygen is now going to be 10 in all. So oxygen is now 10 in all. We have 4 oxygens here. So oxygen is now going to be 10 in all at the right hand side. 6 plus 4. So since carbon is 3 left and right, hydrogen is 8 left and right, carbon now is still 2 at the left but 10 at the right. How do we make carbon balanced? It is simply to make carbon balance, to make oxygen a big pattern. To balance oxygen, therefore, we just simply have to place 5 in front of O2. So 5 times 2 will give us 10. 5 times 2 gives us 10. So it automatically means that oxygen is no longer 2 at the left hand side, but it's 10. No more 2. Carbon is no more 1, but it is now 3. Hydrogen is no more 2, but it is now 8. 2 goes. And oxygen over here is also no more 3, but 6 plus 4, which is 10. So all participants are now balanced. All the participants are now balanced. So this is how to balance any chemical equation. This is how chemical equations are balanced. So now we have balanced 4 equations. Let us look at the 5th equation. The 5th equation is tin 4 oxide plus hydrogen, SnO2 plus hydrogen, to give us tin plus H2O. to give us tin plus H2O. So how do we balance that equation 2? Let us look at it. We have tin 4 oxide plus hydrogen. That gives us tin plus H2O. How do we balance that equation? So to balance the equation on the board, we simply have to follow our steps and rules. Tin is 1 left, oxygen is 2 left, hydrogen is 2 also. Hydrogen is 2 at the left. So hydrogen is 2 also at the left hand side. So we are done with that. Now coming to the right hand side, tin is 1, oxygen is 1, hydrogen is 2. So we can see tin is 1, 1, left and right. Hydrogen is 2, 2, left and right. But oxygen has problem, 2, 1, left and right. So how do we make oxygen balance? To balance oxygen, we simply say, place 2 in front of H2O. So oxygen now becomes 2. Placing 2 in front of H2O, oxygen now becomes 2 and no more 1. But that 2 has affected hydrogen. Hydrogen is now going to be 2 times 2, which is 4. Hydrogen is now going to be 2 times 2, which is 4. But oxygen is just 2, so that it balances with 2 at the left-hand side. But hydrogen now is 4 at the right, but 2 at the left. So how do we balance hydrogen? To balance hydrogen now is to just place 2 in front of H2 at the left. So we can see, we said in the rules that in trying to balance an unbalanced species, we may alter a species that is already balanced. And if that is done, we still have to search for coefficients that will now balance the species that has been altered. So, in a nutshell, all participants or all species must be balanced before we call it quits in any chemical equation. So, looking at what we have on the screen now, sulfur is 1 at the left and it is 1 at the right. So, sulfur is balanced. Oxygen is 2 at the left and it is now 2 at the right. So, oxygen also is balanced. Hydrogen is now 4 at the left hand side, no longer 2. And at the right hand side, hydrogen is also 4 and no longer 2. So, it is balanced. And this is how to balance any chemical equation. So, dear students, I want to believe that at this juncture, you must have learned the method of balancing any given equation whatsoever. So, I now put you to the test to attempt balancing the equation 6, equation 7, and equation 8. Can you do that? I want you to attempt that.